Okay, hi guys. Today we will be deriving the quadratic formula. Let's quickly remind ourselves what a quadratic is. It's a polynomial of degree 2. So you can say this is a quadratic where a, b and c are constants and x is your variable. Now, the quadratic formula deals with where your quadratic is equal to 0, and it will tell you what x is. So let's just start off. Having our ax squared plus bx plus c equal to 0, minusing c from both sides would get ax squared plus bx is equal to negative c. Now, if I divide both sides by a, we get x squared plus b over ax is equal to negative c over a. And now we're going to have to do a technique called completing the square. Now, how do you complete the square? Let me remind you. Let's say I have something like I plus j squared. This will equal I squared plus 2ij plus j squared. Now, if you don't know this off by heart, you can always do the FOIL method, but I won't show it here. I'm sure there's plenty of good things on YouTube to show you. But because of this, if I do I plus j squared minus j squared, then I get I squared plus 2ij because I've minus j squared from both sides. Now, this is what you'd normally call completing the square. So, I want my I squared plus 2ij to equal x squared plus b over ax. So, if I, wrong pen, have x plus something squared minus that same something squared, then I want to get x squared plus b over ax. Now, obviously, our I is x in this because we have x squared. Now, b over a has got to be our 2j. So, write it over here. B over a equal to 2j would imply that rj is equal to b over 2a. So let's fill it in. So x plus b over 2a squared minus b over 2a all squared is equal to x squared plus b over ax. So now I've completed the square, I'm just going to expand and add. Actually, I'll expand it. No, I'm going to add our b over 2a squared first. To both sides, this will give us x plus b over 2a all squared is equal to b over 2a squared minus c over a. Now, sorry that I forgot to update this. Jeez. So, remember from up here that x squared plus b over ax is equal to negative c over a. So I'm just going to write that here. So it's easier to follow. So that would imply that adding it, ignore this part, I'm adding it to the other part. X plus b over 2a squared is equal to b over 2a all squared minus c over a. So if I'm going to expand this part here, then I get x plus b over 2a all squared is equal to b squared over 4a squared minus c over a. Now, I want to make this a common denominator, so what I'm going to do is times this by 4a over 4a. Why? well, 4a over 4a is equal to 1, and a times 4a is 4a squared. So I can just write x plus b over 2a all squared is equal to b squared minus, expanding this, 4ac, common denominator, 4a squared. Now, I want to take the square root, but remember, with an equation, if I have, say, x squared equals a, I know this is a bit confusing, sorry, that would imply that x is equal to plus or minus the square root of a, because obviously this is because negative 1 squared is equal to just positive 1, and negative anything is equal to negative 1 times that thing. So that's the reason behind it, that we have the plus and minus. So if I take the square root, then I get x plus b over 2a is equal to plus or minus b squared, plus or minus the square root, sorry, of b squared minus 4ac all over 4a squared. Now, if you remember how to use your indices, then we are allowed to just split this into plus or minus square root of b squared minus 4ac all over square root of 4a squared, which is of course plus or minus square root of b squared minus 4ac. Sorry, that is supposed to be a minus, please remember. This 4a squared, square root of 4a squared is just 2a. So, minusing b over 2a on both sides, we get x is equal to negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. And as you can see, we have a common denominator here, so I can just write that as x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And there's our quadratic formula, and that's how you derive it. Let me do a nice little aside here, a little thing that I thought was kind of cool. So you see this negative b over 2a term? Well, don't worry if you don't know what this is, but if I differentiate our polynomial, our quadratic, then we get this, 2ax plus b. Now, this is going to tell you the gradient at any point. At the minimum or maximum point, the gradient will be 0. So, setting this equal to 0 would imply that 2ax is equal to negative b, which would imply that x is equal to negative b over 2a. See how it shows up in our quadratic formula? Both roots are the same distance from the minimum or maximum as the other. Or you could say the minimum or maximum is in between both roots, which I just thought was a bit cool. Yeah, hope you enjoyed, guys. I will see you in the next one. Peace.